Hello everyone, welcome to this video. I want to make a series about a set of architectural patterns that are commonly used in enterprises. Usually, small customers or small enterprise will not really bother with all these details, but I think they should. And the problem with it is that there is a pretty huge barrier to entry. You have to know a lot about different things in order to do a very secure setup that, like a one used in enterprise. And given that I worked a lot in deploying a lot of solutions and architecting a lot of solutions for enterprises, I maybe want to share that kind of knowledge to, make it easier for a smaller company who can't afford, someone to come and build such a setup for it. If you can't afford to pay for a service, basically, how would you actually go ahead and do it? I will be focusing in these series of videos only on Azure. I mean, maybe later on we can discuss doing the same thing on other cloud providers like AWS or GCP. But for now, I want to focus on Azure just because this is where I feel more comfortable and I've done it plenty of times before on Azure. So let's go ahead and get started. So the first thing I want to talk about is, well, basically the quick and dirty way of doing it. Let's say you're a small company that just want to get its website up and running on Azure. The first thing you would do is just coming here, and deploying such a setup. And I'm just gonna show you very quickly how that would look like. I'm just gonna create a brand new resource group, and I'm gonna throw this away in a while, so I'm gonna call it throwaway. You can put it whenever. I want to put it somewhere close to me, just for it to be, if I ever want to access it, to be faster. And I'm deploying. That usually takes a couple of seconds. We can, like, for such things, like when we're waiting for something to happen, I'll pause the video and then we'll resume after it's done. And now let's deploy a web app. So you can come here, click I want to deploy a web app, and the web app name would be something like test web app, and then I'm just gonna put some gibberish so that it doesn't conflict with anything else. You can choose what exactly do you want to deploy. Do you just want to deploy your code, or do you want to deploy a Docker container? I'm gonna go ahead with a Docker container just to have something on there, and I'm gonna use an existing container for it. We will discuss later about, containers and what more you can do with them. And this is basically the size of the app service plan. An app service plan is basically a server, or like it's the unit that you pay for. So you can have as many web apps as you want inside a single app service plan, and the app service plan is the unit that you pay for. It contains everything that you need in terms of like load balancers and all the underlying infrastructure that you need to run multiple websites on it. But I'm only going to use it to deploy just one website, and then we'll see. So the next is the Docker, and like what do you want to deploy here? I will deploy a default Nginx container, just the quickest thing I can deploy that can give me an output. Whether I want monitoring or not, we will talk about monitoring later, but I don't want to go into this right now. And I'm just gonna review and create. That usually takes a couple of seconds to create. And for that, I'm just gonna click create here and then pause the video so that you can, so I don't waste your time. So we're done. That took about a minute to be done. I'm just gonna go to the resource that we just created. And here's my test web app. Of course, this is just a random name that I picked. You probably want to do something more descriptive about what you're deploying. And here's the website, and I can click it, and there you go. There is my Nginx server running inside this application. As far as most people will be concerned, this is good. I mean, it has a bad URL, but like you probably want to use your own custom domain for it. And the way you do that is you come here to custom domains and you register your domain. So you either buy a domain or add a custom domain, add your own. And there are many ways to verify your domain. We're not going to do that right now. I don't want to focus on this right now. We'll do other things later. And also you can put an SSL certificate. What kind of other protections that you can get? Well, nothing really. That's it. If you want to put this web application behind a web application firewall, I mean, you can, but there's a very convoluted way that you can go ahead and do that. If you want to go ahead and put this application behind a firewall, that's all fine. You can do that. You can have a web application firewall on Azure as well, and make it point to that other like forward basically proxy requests to this URL, and things will work fine, and you can reach it using your proper domain. The main problem is that this URL will still be available. So what you're gonna do is come here to something like networking and add what we call a network restriction or an access restriction, which basically restricts the access for this website only to a specific set of servers, possibly your web application firewall servers. It's pretty easy to do. Like you can hear just what's the URL or what's the the IP address that you're expecting to contact this, and basically you want to deny all and just allow a single IP address. Can you actually reach this website privately? Or can it exist in a completely private fashion? And this type of app service doesn't. What we need to do is another setup, which is an app service environment, which is this one. And an app service environment basically allows the whole app service to live inside a virtual network. And the only way you can access this is using the application gateway, which is your own web application firewall. So you'll be in total control of who can or cannot access this. Also, you might want to host some applications that are only internally available. So these applications are available only through your VNet. You don't want to publicly expose them. And for that purpose, choosing this type of app service is not really the best way to go. I mean, you can put your application here, your app service inside a VNet using the VNet integration, but that's mainly for it to reach others, not for others to reach it. That's the only differentiator between this and an Azure App Service environment. An Azure App Service environment is a dedicated environment just for you. It lives completely within the VNet, and you can control what kind of load balancer you want to put on it. So this app service environment has a load balancer attached to it, and you can choose whether you want an external load balancer, meaning that yes, the app service environment lives within the VNet, but it has also a public load balancer that connects externally. I think that defeats the purpose a little bit. And the other type is an internal load balancer, which they call ILB ASE. You can see more about it here, which is an internal ASE. And that one basically lives only within your VNet, and it has an internal endpoint rather than external endpoint. The benefit of that is that you can host applications, host websites and APIs and what have you internally inside your own VNet. That VNet, in most cases, in enterprises, will be connected to a VPN where it connects to their internal, network, and therefore they can reach this application from an on-premise location, even though, or from a branch location, even though it's hosted in Azure, they are still doing it securely through the VPN into the VNet, and they're not getting exposed outside whatsoever. And you can choose whatever you wanna expose outside. And it's also a pretty good setup for having your own web application firewall. So in such case that you want to host a big application, everything is hosted internally. However, you have an application gateway that is controlling, and this can have a web application firewall component to it. So it does, stuff like mitigation for SQL injection and request manipulation and that sort of thing. So it gives you a lot of protections that you might need for a secure web application. And that's the way it's done. We will see how to do this. What I just want to talk about is that doing this, an app service environment that is hosted only internally inside your virtual network, will provide a lot of challenges for your CI/CD pipelines. Like, what if you're using you want to basically automate the deployment of your code onto this application. Like, you have a code repository where this application exists, and every time a new commit happens on the repository, you want to push the new version of the code maybe to a development environment or a testing environment that exists on this app service and that is also only accessible internally, and have it like that. So this deployment, because the app service environment lives completely within the virtual network, your CI/CD pipelines might not be able to reach it. Like if you're using something like GitHub Actions or Azure DevOps or something like that. So we'll also talk about how you can mitigate these sort of issues and show you ways to circumvent them. So I want to go ahead and create this setup. This is all fine, what you see here from an architecture perspective, but there is a lot of details missing. Like, what's my subnetting going to look like? What's like, I still don't know how to handle this. So we'll take a look together at, the way I see most enterprises doing it. I'm just going to throw away this throwaway resource group, just cleaning up after myself. Now I'm gonna use the GUI right now, but everything we do, I'm also gonna make sure to do it using the command line for those of you who want to automate it, and I'll also be sharing the code for this so that you can follow up later. So I'm just gonna do this, and now I'm deleting this. I don't need to look at it, it's deleting by itself. And then I'm gonna add this. So this resource group, let's call it ILB ASE demo, and that's good for me. And I'll create the resource group. We can add the resources. So the first thing I want to do is a virtual network. Oops, sorry about that. I'm doing the wrong thing. So I want to create a resource. That resource is a virtual network, and this is where the ASE is going to live. And the process of creating a virtual network is pretty simple. If you're familiar with any virtualization environment, it's more or less the same. So I'm gonna call it ILB ASE demo, and just I'm gonna put, the proper way to do things here is just to like name it something that describes what this object is, so that later on by just looking you know what's up. So the IP address scheme, something a little bit important about the IP address scheme that I want to mention here is that you want to choose an IP address scheme that does not conflict with any other thing that you're going to connect to later on. An example of that, if you have an on-premise environment, and what we are doing now is we are creating an app service environment that lives within the VNet for the sole purpose of being able to access these resources privately. So you can, you bet that you're going to need to reach these IP addresses from on-premise. And if this conflicts with your on-premise IP address scheme, then you cannot do that. You cannot create a VPN connection unless you go into like very complex ways of netting, and you don't want to do that. It's just easier to use something that is completely isolated and completely different from anything else. So for my purposes, I'm gonna choose a very much smaller subnet. And I'm gonna call it like a /24 subnet basically would be enough for me. So I'm gonna do that, and I will assume that my on-premise environment uses 10.0.0. So I'm gonna use something like 10.1 um, dot 0, and that's just fine. So I'm gonna add a subnet. I wanna do my own subnet scheme. So there are a few subnets that we're gonna need. I usually like to start with a management subnet. And the management subnet purpose is like to put any management tool I wanna put inside here. And that's gonna be something like 10.1.0.0 / a 27 is gonna be fine for it. That's like 32 IP addresses. I don't think I'll need more than that. And then you can create something like, if you're ever having an ASE, so this is going to be an applications subnet. And this is going to be 10.1.0.32/27. That's also wide enough for the purpose that I'm using. You remember that we're exposing this entire ASE with all the applications inside it into just a single load balancer IP address. I mean, you can have more, but why would you? So this is going to be fine enough for me as well. Then we're probably going to need a front end subnet. This is where this is going to live, which is the application gateway. And this is the front end. This is what you are going, like what other people are going to access. Before doing that, let me also, there's a pretty important component that people like to also separate in its own subnet in most cases, and that's .64/27. That's also wide enough for all my databases, I think, and that's gonna be good. And then we're gonna do the front end subnet, and that is 10.1.0.0. Sorry, is it 96? I'm bad at math. Sorry, 27. All right, yeah, that looks about right. So these are the 4 subnets, and I'm just gonna click next. These are some, like if you want to enable DDoS protection, if you want to have an Azure Firewall in it, that will create an Azure Firewall subnet. And if you want a Bastion host, that will create a Bastion host subnet as well. I don't want to do this right now. Like, these are very good features, but I don't want to enable them because they're additional cost, and I don't want to pay for it right now. And let's create my my VNet. Now, if you're ever going to create a Bastion host or create a firewall or something like that, in this VNet, you might want to leave some space for the Bastion host subnet and the Azure Firewall subnet. They require certain sizes. I think /26 or /27 is a required minimum for these two. I don't remember. You will find it in the documentation. So you want to leave space for it for if you're ever doing that. And the other thing worth mentioning is that if you're ever pre-creating these subnets, you're not like, if you want to pre-create a subnet here, it must have a specific name. So this is going to be called Azure Bastion host subnet, and so Azure Bastion subnet, and this is called Azure Firewall subnet. It must have a specific name with a specific camel case capitalization and all that sort of good stuff. And that's just worth mentioning. You'll find these things in documentation. They're pretty specific about what you should name these and how wide they must be. And now let's create. So that should take like a second. It never takes more than 30 seconds. So I'm not gonna pause it, just let it do its thing. It's usually very quick. So what we created right now is the VNet. What we're creating right now is the VNet that has all these subnets, but we didn't discuss the issue of a VPN. If I want to have a VPN, what should I do? And for that, you need to create an additional subnet. It's called the gateway subnet. And there's a pretty easy way to do it. It's just to come here into subnets and, add a gateway subnet. And usually you want it in the absolute end of it. So I think it's 228 slash, or like, sorry, 220 4/27 is good enough for it. That basically takes like the tail end of this VNet to create the gateway subnet for it. I'm not going to do that because I'm not going to create a VPN, but in case you wanted to create a VPN, that's one alternative you have, is to put the gateway subnet here and then create an Azure VPN on this gateway subnet. The other alternative is to actually, if you have another VNet with a gateway subnet already existing in it and it already has a VPN established, then you can just simply peer this VNet that you created right here with this other subnet. Again, notwithstanding any conflicts into like, you should make sure that this does not conflict in the IP addresses in any shape, way, or form. So now our VNet is ready. So now we can go ahead and go back to my ILB ASE demo, and I wanna add an app service environment. Sorry, it always does that. I don't know why. And I'm now searching for the app service environment that I want to deploy. There it is. Create. And I can name it whatever I want. I'll call it ILB ASE demo as well. Let's see if this name's taken. It is not. And I'll choose internal here. I want it completely isolated from everything else. This just exposes the hosted apps on the internet accessible IP address. I think that completely defeats the purpose of having an app service environment, but there are other cases where you might need an app service environment as well, and it's worth having this option just for future reference. But if your sole purpose of creating an app service environment is just privacy, then an internal is the thing that you want to choose here. Then this is basically what operating system support you want to have. I'm gonna create Linux, just faster, and that's what most people want to do, so I want to stick to that. And this is basically telling me where do you want to deploy this. So I want to deploy it in my application subnet. I didn't have to choose the VNet because that's the only VNet I have, so it's just assumed so. And I'm gonna put it right here. And then review and create. Now, this is going to take over an hour to provision. Once I click here, I'm just going to click create and we're going to wait for it to do. You should also know that there are specific costs associated with an app service environment. It's quite pricey. Like, I think Microsoft is going to roll out soon another way of billing for the app service environment, so you don't have to pay it fully and you can just pay for like pay as you go, same as you do with other types of like only pay for the apps, not for the entire app service environment itself. So we will see how we do that. So I'm gonna pause the recording and we can come back later when it's done, because this is gonna take about an hour. So finally we're back. The deployment is complete. This took about 2 hours and 15 minutes, quite a lot longer than usual. But we're gonna go ahead and get started here. So this is our app service environment, and just waiting a second until this populates here. You can see here, this is the domain name. Now that does not exist anywhere. This is just the name that it names itself internally, but we're gonna have to go and create a private DNS zone for this. I think it used to do that by itself, but now it doesn't do that anymore. And this is the virtual network we're attached to, and it's in the application subnet. And you can see we have no app service plans and we have no applications or slots in there. So it's quite empty because evidently we just created it. So now let's go ahead and try to create an application in there. And I'm gonna create a resource and I'm gonna create an app service plan. Now you could just go ahead and create a web app and you know that create an app service plan while you're doing it. I just want to be a little bit more deliberate about the steps I take so that you know you follow each and everything we're doing. And I'm gonna call it app service plan ASP, and we're gonna call it ILB ASE demo. And the location, so I could choose a data center, but I don't need to do that anymore, because if you come here and see app service environments, I already have my app service environment. So I'm basically deploying the app service plan on the environment that I've previously created. And then I create. Now this is the smallest size you can create. You have to, of course, choose an isolated plan. These are the only type of plans that go into app service environments. Not that much expensive than a premium plan, but it's just you pay for the app service environment itself, on the other hand, which is a little bit more pricey. So we're gonna go ahead and create in this app service plan, and in essence, what this is, it's creating a server in the background, like a web server that you're going to use to host these web apps that you deploy. So again, this shouldn't take long, so I'll just pause and we'll see. So now we're back. I was mistaken, actually. That took about an hour, not 5 minutes at all. I think I was confusing it with the app services that you create. So the consequent app services are going to be much faster. Typically, also, if you're doing this, like if you're doing an app service plan that is not on an app service environment, it's going to be much faster as well. So here we have the app service plan. That's basically a server farm, like one or more servers, and you can tell by looking at like this, like you can scale up like how big is a server in this server farm, or you can scale out the number of servers you have in the server farm as well. I really don't intend to talk about like custom scaling and all the good stuff. There's plenty of tutorials out there for that stuff. So, and now we can deploy our app. So let's go ahead and deploy our application. So actually, you can just deploy a web app. That's just the easiest way you can do it. And the resource group is going to be the same resource group we've been using. The name is gonna be, let's say, ILB ASE demo.azurewebsites.net. And the plan, we're going to choose the plan. So again, the region here, we choose the region that we previously made. I'm sorry if I seem hesitant, this is completely unscripted. So here we chose our app service environment as a destination for this app service. And the app service plan, I'm going to choose the existing app service plan that I just created. I don't need to create a new one. And then again, I'm just going to use Nginx as a Docker container and review and create. That should not take any more time. I hope I'm not mistaken again. And we'll pause and we'll get back when it's done. And that took about 30 seconds to be done. So there you go. This is the web app that we created. It's running Nginx, and there's the URL. And if I click on it, well, nothing will happen because there is no way I can resolve this URL. Even if I could resolve this URL, this is on an internal network. So let me give you an example here. Sorry, if I go to properties. I think I mean the properties of the app service plan, but this is the outbound IP, like if this were to make external calls, where we go. but the virtual IP address is right here. This is the IP address of this web app. And there's just no way it can resolve because this is within the VNet. So if I had a VM in this VNet, it would be able to reach this IP address. It still wouldn't be able to resolve this address because there's no DNS resolving to it. So I think that's the first thing we're gonna fix. So before we do that, let me just create a very quick server. And I'm just gonna create an Ubuntu server. And I'm gonna put it on the same VNet so that we can test whether our application is running or not. I'll put it in the same resource group. I'll call it VM ILB ASE demo. And I'm just choosing the smallest one I can right now. I'll just also choose a password. Let's call it vmadmin. And I'm gonna use a trusty password here. And I want to open this port. And in the networking part, I'm gonna choose that this exists in the VNet that we created. And I'm going to also make sure it's put into the management subnet. And I think that's all the configuration we need. I don't need anything more. So let's just create. And that's a warning that I have an SSH port open to the internet. Of course, this is where Bastion hosts would come in, or maybe create a jump box. There's even a good feature with Azure Security Center where you can request the port to be open just for a specific period of time until you do your connection and do whatever you want to do, and then it would close up after you. I'm not going to go into this right now. So hopefully this server doesn't take long to deploy. I think it takes like a couple of minutes or something. And we'll wait for it until it's done. So the deployment has been completed. I think it took a couple of minutes. So now I go to the resource and let's SSH into the server. And just to prove to you that I can reach the this from within the server. So I actually don't need any of that. I did not create an SSH key. I just chose to use a password. So I'm just gonna go into my terminal here and I'm gonna do SSH, and then this is the username at the IP address of the server. And the password. There you go, and we're in. I'm just gonna enlarge this a little bit so you could see better. And now I'm in the server. This server is on the VNet, so theoretically speaking, if I do curl and let's do a verbose 10.1.0.43, I think it was. That's the, let's double check. That was the web app's IP address. And if I have to, if I were to do another web app on the same app service plan, it would have the same IP address. It's looking for the host header to know which web server I'm trying to access. This is why I don't know whether this will work or not. But yeah, that's the correct IP address. So let's try. So so it's giving me something. I mean, it's responding, but it's not responding properly. And this is because of the same thing I just told you, that all the web apps that I'm going to create on the same app service plan respond on the same virtual IP address. So how does it know which web app am I requesting? So if I was requesting the web app, like if I was requesting this domain name, then if this was the host header I'm trying to request, it would work. And so let's try that. I actually think there is a command line that I can do to do that. So we're gonna ask curl to do this resolution for me. And again, curl dash v and then dash dash resolve. And then I'll tell it to resolve this to 10.1.0.43. And then the URL that I want to access is this one. So I'm making a request to this URL, and I'm just telling curl, hey, by the way, this URL actually resolved to this IP address. So the request is going to go to this IP address, but with this host header. And that didn't seem to work. Yeah, I looked it up, and I think the mistake I'm doing here is I'm not telling it which port, and it should be something like this, I think. And yes, so now we get welcome from Nginx. So now I could reach the website just not from like only from within the VNet. So now let's fix this DNS issue. I don't want to, I don't want to manually resolve this URL all the time. So what I'm gonna go do is I'm gonna go create a private DNS zone, and I'm gonna add here and private DNS zone. And you have to be specific because there is a normal like public DNS zone in Azure, and if you just choose DNS zone, it would create a public one, but you have to be specific and say private DNS zone, and that's how you create a private one. Because you can't create just public DNS zones on Azure and they're just called DNS zones. So here is the resource group we're deploying this in, and this is the name of the DNS zone I'm creating, and I want to remove the first part. Like I pasted the name of the web app, but I want to remove the first part here because this is going to be for all web apps. I want to resolve all web apps on the same app service plan to this IP address. So I'm just gonna do this, creating the zone. And that usually takes a few seconds. It's not a large deployment at all, so I don't even think we need to pause. And then we're going to use this DNS zone to make a resolution. So DNS zones are different from like public DNS zones, is that you can attach them to a VNet, and they like Azure is smart enough to know that when you attach a DNS zone to a VNet, then you want to basically set the DNS server for everything inside this VNet to refer to this or to forward the DNS request to this DNS zone that you're just creating. So it's just going to take care of itself once we attach it to the VNet. The private DNS zone by itself just doesn't do anything. We need to, well, you can forward requests to it, but you need to specifically choose, well, which virtual network am I linking this to? And here I'm going to go to virtual network links. I'm going to add, and the link name, it can be anything you want. So I'll just call it ILB ASE demo DNS link. Doesn't matter at all. And which virtual network, and I'm choosing my VNet, so I'm attaching this DNS zone to my VNet, so it's going to be consulted each time someone asks, well, what's the IP address of something under this domain name? It's going to be responsible for responding to it. And if you enable auto registration, it just registers every single server that you create on the VNet automatically onto this DNS. I don't want to do that. This is just for the purposes of ASE. So I don't really want to do that. I'm just creating the link here. It should take a second. It doesn't take long at all. And then I want to have some records in this DNS. So I'm not going to wait until the link is created. I can actually go ahead here and add a record set. And the record set I want to do is, well, asterisk means anything inside like .il based demo, but anything under this, doesn't matter which web app always go to 10.1.0.43. And there you go. So now adding the record set. So now once I did this, now theoretically speaking, if I come here, I should be able to do ns lookup on this, and it did actually in fact respond with the proper IP address. So now I don't need to type this convoluted curl command anymore. I can just do HTTP and this URL, and there you go. It works now. So now that's the DNS taken care of. What's still not taken care of is, well, like, how do I make it accessible over the internet? To be honest, so this is usually one of the things that a lot of environments really don't like. In reality, you will rarely need to do this, but some people also like to have this option. So maybe you have an application that is hosted internally differently than it's hosted externally. In such case, you may want to do this. In other cases, just a lot of people prefer to use an app service environment and have everything secured internally, maybe because they have a source control system that is independent of the internet and it's only put internal, and they want to be able to push their code internally only, and their code must exist in an internal network all the time at all points in time, and they never want to expose it outside. So that's also one way that you can do it. And that's why people use an app service environment for it. But generally speaking, if you were publishing a website externally to the public internet where, you know, random people can just access it, then you probably don't need an app service environment. There's only fringe cases where you do that, where, for example, as I said, your code is so important to you that you don't want to put it on the internet. You have a private repository where the code lives. You have a private CI/CD pipeline that is only existing on the internal network, but you still want to be able to push your code to the server. So you want the server to exist internally. Also, another way of doing it is that if you have another service inside your organization, and this service that is inside your organization needs to talk to this website, but it cannot have internet access. Of course, you could proxy with all the problems that proxying has, but you can also do this, and that just makes the service available internally and externally at the same time. So you could reach it without internet, and you could reach it with the internet. But let's get back and let's focus to what we're about to do. We want to expose this website to the outside world. But first, let me get started with the deployment, because it takes quite a while as well. So we want to deploy here an application gateway. And that's going to be responsible for taking an entirely private resource and exposing it publicly. And gateway, ILB ASE demo. I also wanted in West Europe. So now here where you choose, okay, now I want to have a web application firewall, for example, instead of a standard firewall or like a standard proxy. I'm gonna do this just to show you the bit of features that come with it, but I don't really need to do it. I also don't need auto scaling, and one scale unit is gonna be fine for my purposes, but just know that you can really auto scale this as much as you want. The firewall status is enabled and it's in detection mode. Detection means that it's not going to prevent anything. It's just going to detect it and log it if it finds something wrong, but it's gonna let the connection go through. That's good for dev workloads, but once you go production, you probably want to set it to prevention mode. The problem is some tools like conflict a little bit with the rules that firewalls put in place. So I know for a fact, for example, that if you're hosting WordPress, you would have a lot of trouble accessing, or the admin interface in WordPress, like the dashboard behaving properly if you set it to prevention mode. So that might be something that you want to test. Maybe you want to tune some of the settings in the firewall just to make sure that it doesn't, break anything or something like that. And then you got to choose which virtual network this is existing to. Now, application gateway understands that it's usually exposing a private resource externally, so it expects you to put it on a VNet. And here I choose the VNet I want to use, and I also choose which subnet, and we're going to choose, of course, the front-end subnet, which we pre-created for that purpose. Next, I'm gonna choose the front ends, and that basically is what is the front end IP address I want to use. So I'm gonna just choose a new public IP address and then call it pip ILB, like pip gateway ILB ASE demo. And that just is it has to be standard, it has to be static. There is no option here if you want to use it with application gateway, and that's just a public IP that I want to use to talk to this. And next I choose the backends, and basically the backends is what is the backend server you want to talk to, and here is going to be ILB ASE demo. And do I want to create a backend pool without a target? Well, I could, but I don't really need to. But here the target is going to be the application I'm choosing. You could also choose app services. I don't know whether it would pick it up or not. It actually would, so that's good. So I can just choose this as the backend, and it would automatically, if for any reason whatsoever it changes the IP address, it will automatically pick that up. Not that would ever happen, but there you go. And the configuration, now you have a front end that to receive the connection on, and you have a back end that actually you proxy the connection to. Now you gotta set some rules, which are like what routing rules are you using in the middle. And the first thing is you create a listener. So let me go through this configuration. I'll try to explain as much as possible, but then I'll switch my screen to something to explain the concept of how this all works. So the rule name can be anything you want. I'll just call it ILB ASE demo rule. And the listener name, I also can create any sort of listener I want. And the front end IP, well, I just chose the public IP address that I just created in the previous step, which is this one. And here I'm talking like what protocol is this in? Is it HTTP or HTTPS? So if I do HTTPS, I have to choose a key from the KeyVault. I don't really need to do that right now. I'm just gonna focus on just the non-secure protocol, although you shouldn't really do that. The listener types, you have either a multi-site listener or a basic listener. A basic listener will basically look at all the requests that come to this IP address and blindly forward them to the backend target that you have. A multi-site listener will listen for a specific host header, like a specific address that you're asking, like for example www.something.com. And if you do that, then you can have multiple host names inside the same application gateway, which is pretty cost efficient. If it's not getting hammered with traffic, then that's a pretty cost efficient way to do things. But now you have to know, okay, you have to have public DNS access or something like that. We have that. I just don't want to do this right now. I want to focus on the most simple scenario, and that's the basic listener. And then you have to do the backend targets, which is fine. This listener I'm doing listens on this public IP address, on this port, on this protocol, and anything that comes to it, it's going to proxy it, but where? And here you choose where it proxies. And the backend target is the backend target we previously created. The HTTP settings is while you're proxying this, do you want to make any changes to the request, or what are the settings that you wanna talk to, wanna use when you talk to this backend target? So maybe this backend target expects from you something like unique when it's talking, and we know that ours does. So for example, if I add new here, I'm gonna call it ILB ASE demo settings, and ours expects a specific host name. And here I want to override the host name. So if you're talking to me using, www.mywebsite.com, don't just forward the same host header to the backend, because it doesn't know what that is. The backend only knows this name, which is, let me copy it from the terminal here. It only knows this name. Oops. Sorry about that. Again. So you could pick the host name from the backend target. That's if the backend target itself had a host name. That would work in our case, I guess, because we're using an app service environment, but that is a more concise way of doing it. And again, do you want to use a custom probe? You bet that you want to use a custom probe in this case. The probe is the thing that, how do you know this backend is alive? So you probe it, you keep asking it, are you alive? Are you alive? Are you alive? It's like a ping. But it's like an HTTP kind of health check. So if you create a custom probe, you're going to use the same settings right here. And I think that's enough for this part. That's going to work. And you can also do path-based rules, which is, for example, if you do /customers, it goes to server 1, but if you do /orders, it goes to another server, and so on. I'm not going to do that. We don't have any of that right here. That is our configuration, and I'm going to create this. And just double checking so that we don't have to repeat ourselves. Yep, that's good enough. So that takes a while, like I think about 30 minutes or something until it's done. So I'm also going to stop the recording. And maybe it's time to talk about some theory behind application gateway, so you guys understand all the things that I just did. And we come back later. So in application insights, we're going to have a person right here who's actually talking to a public IP address. This public IP address is associated with a listener. The listener is like what listens for incoming connections, and you can have two types of listeners right here. You can have either a basic listener or a multi-site listener. So the basic listener will just blindly take everything coming from the public IP address and just blindly forward that to the backend. The multi-site one is going to first look at the host header, and based on the host header, it's going to determine the proper backend to send to. So these are the two objects. And then you're going to have here something called backends. Backend targets, to be more specific. And the backend targets are what is like the definition of what actually carries the connection. Like what actually you're talking to. So this is your backend server or backend service or whatever that may be, a VM, whatever you want. However, when you do this part right here is called a rule, and the rule just determines, well, maybe you have a specific path, right, you want to listen to. Nonetheless, this rule is what decides what's going, like when you get what request goes where and so on. So it just ties everything together. The part that is important to understand is, well, while you are talking to this backend, there is also an HTTP setting. And the HTTP setting is basically what settings do I use to talk to the backend? So these could be stuff like, is it waiting for a specific host header for me? Do I need to maybe change the port? So maybe I'm receiving this like I'm listening on port 443 because I'm securing my app, but then my backend is not secure and it doesn't need to be, it's only internal. So I maybe, what's the actual port I'm making the connection on? What's the protocol? If it's secure by a self-signed certificate, what is there a custom CA I need to know about? I need to trust to know that this is actually my website. There are settings like affinity, which is if this user does all this cycle and goes, I can have multiple backend targets on the same rule. So it's something like hit server 1 or server 2, it doesn't matter. But then if this person hits server 1, maybe he caches a profile on server 1 or something like that. So next time he makes another request, I need to be sure that it goes to the same server. So that's the affinity part to be set up, and also like how do you do this affinity? Is it like cookie based? So there's like cookies also to be configured. There's plenty of stuff to be configured in this HTTP settings, and that's one of the most confusing things I find. People getting confused when they're getting to know application gateway is what does this HTTP setting actually do? Well, these are the set of rules that you use when you're talking to your backend target. You configure all these things here. Now also, Application Gateway is not going to relay these connections until it knows that this backend target is healthy and alive. So how does it do that? So there's something else called the probe or health probe. And the health probe is just a way to ask, well, is this website healthy? So it's just something that maybe exists, like it tries to make an HTTP request using these HTTP settings, or maybe you have a different set of settings. So Application Gateway has the flexibility to allow you to use a different set of HTTP settings for your health probing. You could use the same settings. If that's the case, then you say, I don't want to a custom probe at all. It will just use the same HTTP settings. But evidently, you can use a specific set of rules or a specific set of settings to do your health probing. Maybe you need a specific URL to access, like something like my website.com /status. So how is application going to know about this part? It's in the health probe configuration. Because if this page returns a proper result, then the application is doing fine. And this page would give an error 400 or something if it's not a proper, if the website is not functioning properly. Because Application Insights wants you to make sure before a backend target is ready to receive connections, it has a proper health. Also in this part right here, we have a bit of configuration called rewrites that you can do, which is basically header rewrites. And that's not only this way, it's also back and forth. So the header rewrites can be back and forth. So for example, as you are sending or as the listener receives the communication, it has the ability to rewrite some headers. So maybe, change this header, add this token, do this, do that, whatever. Maybe your internal service or your backend is so secure that it has a token that you need to talk to it. So this is where you would inject your token. You would just create a new header to put this token in, and then maybe on the way back you have another rewrite to pull that token out so it doesn't get to the end user at the end. So this is just a bit of theory about application gateway and how it works. And now we'll jump back to the page and see what happened. And so now we can see the application gateway configuration is completed. So now let's go to this guy right here. Okay, so we know there is a public IP address that we have chose. We created, I mean, for this thing. But this public IP address, there's nothing that resolves to it. I don't have a DNS entry of, you know, www.myfancywebsite.com that points to this. So as a temporary measure, I'm just gonna use this configuration right here, and I'm gonna choose a label, and let's call it, you know, again, ILB ASE demo. And it's going to be this URL, .westeurope.cloudapp.azure.com. That's just I'm going to depend on Azure to create this just sample DNS label for me. And the reason I'm doing this is I need something to type in the browser rather than just using the IP address. It just looks nicer. And I'm just gonna wait until this refreshes. I should find the DNS name here when it's saved. It should take just a moment. Didn't it? Well, yeah, here it is. Okay. Now I can copy this, and this is the address that I'm listening on. So let's see what happens here. Before I do, I want to make sure that my application gateway is working fine. So the way you do this, just so you don't waste your time. So I could just type this and it would work, but I also want to make sure that I show you how do I know that it's working, is to go to the backend health right here. And here, if there's a problem locating the backend or communicating with the backend using the current settings or whatever, it's going to show up here. So it just takes a while to probe because this is where it does all the health probing and so on, and see it's healthy. So I could reach actually the backend. So I come type this, and there you go. My application is published externally. So this way I have an application right here that I have an application on this listener that actually is like this. This application gateway is exposing an internal, completely private application to the internet. Oh yeah, the firewall. All right. Yeah. So we could see that here I'm just doing the detection mode, but if I set it to prevention, well, maybe some things will break. I doubt something will break with this. But if you have something that is breaking, you can find these breaks in the logs, and the way you collect the logs is just you go to diagnostic settings, and add a diagnostic setting, and then the application gateway firewall log. This is basically going to tell you whenever a request is blocked because of anything, and you send this to log analytics, and you have to create a log analytics workspace, but then all the logs are sent to this workspace, and then you can search the logs to see, well, why is my application, why are my requests being blocked? I may be doing something wrong in the way I communicate with my application, so that it's not compliant with the proper firewall rules that should be, or maybe the firewall rules are just too tight for my type of application that I'm using, and I need to relax them a little bit. And the way you can relax these rules are just go back to Application Firewall and go to rules. And so by default, it uses the OWASP 3 rules, and these are just industry standard. But what you can do is do advanced rule configuration. And if one of these rules are, messing up your app, you can just find the offending rule and just uncheck it. That's the easiest way I know that to do this. Or you can use a different standard. These standards change all the time. My guess is the new standard would be even more strict than the old one. So I wouldn't try to use like a different standard just to mitigate that I have a problem maybe with one of my rules that are destroying my app or making my app behaving correctly. or like ruining the customer experience. I would first, well, find out what is this offending rule, and if it's something that I'm doing wrong in my application, like my front end code is doing something that it shouldn't, so I should fix it. But if it's doing something that it should, and this rule is just so obtuse, so just, you know, disable this rule, and that's it. So, okay, what other uses are there for application gateway? Well, the main use is the firewall and also SSL offloading. So I want to be able to put my secure socket layer, sorry, not my TLS certificates. So if I click here, here is my listener, and as you can see, it listens on port 80. You probably want to have a different rule or a different listener listening on port 443, but that requires us to do a proper certificate. And you know what? I actually have a certificate already ready in a KeyVault, so I can actually show you that. So I can come here to listeners and add a listener, and I'm gonna do something like ILB ASE demo secure, and this listens on the same public IP address, but I can't do the same port anymore. The reason being is, well, this port is taken. I have already another rule listening for it. So in this case, I'm gonna choose HTTPS. That's gonna switch this to 443. And now I need to choose a certificate from the KeyVault. So I'm gonna select a managed identity. I don't have this created right now, so first I gotta create a managed identity on my Azure command line to be able to select the certificate from the KeyVault. This basically is, how do I explain this? A managed identity is like a service account. And right now, this gateway does not have any permissions on this KeyVault. So it's not going to help me that I choose this KeyVault right here. And, you know, even if choose the certificate or whatever, it's just not going to work. I need to be able to, and I also need self-deleting enabled, but that's beside the point. I need to be able to have access onto this KeyVault. And the way you do this is by setting a managed identity for this application gateway. So there is a command line that you can do that. It's pretty simple. So I'm just going to cancel out of this right now, and give me a sec. So I stumbled upon this article right here, TLS termination with KeyVault certificates. This is for application gateway. And well, if you see how it works, well, that's basically create a user, assign managed identity, and assign it to the application gateway. And then you create the certificate and access policy in the KeyVault. I already have the KeyVault with a certificate in it, so I don't need to do this step. And then assign identity and KeyVault access certificate reference. It's a pretty simple thing, and you can do it using PowerShell. So the command you would use, I'm only created in assigning the identity. I'll show you the rest in the UI. And this is the identity that just running this command, new AZ user assigned identity. And then you call the identity whatever. It doesn't matter actually what you call it. So I'm just going to copy this command. I don't need, I'm gonna just copy the both of them and manipulate it a little bit. And there it is. Now I'm in PowerShell terminal. So I'm just gonna do like RG equals, and then there is this AZ resource group. I don't need to create a resource group for it. I'm just gonna go get AZ resource group dash name, and I'm gonna the name is, well, what was the name for it? Let's see, this one. And I should have my RG right here. We'll see. I think I need to first do an AZ login. Sorry, I forgot about that. So let me also get the subscription ID here. Just a sec. Subscriptions, and yeah, that's the one. Yeah, it's again connect AZ account subscription is this. And that, I think that's gonna log me into the proper subscription now. Code. There you go. Now I'm in the proper subscription. So now I run the same command. This is my resource group. And then coming back here, I want to create this identity. I don't even need to keep it. I'll just do this. Do this. And sorry. I want to do it in a single line. So I'll copy that. And I actually want to call it gateway ILB ASE demo KeyVault identity. And then the location is West Europe. And then the resource group name, well, I could just do the resource group name ILB ASE demo. I didn't need to run the first line. I'll probably spare you all this in the edit, but let's see. So now the identity has been created. Now I can go back to the portal and go back to my resource groups. Now I want to go back to the KeyVault and give access to this account that I created. What I did right now is just create a service account. Now I need to assign access to it. So I go to my KeyVault, where the certificate lives. And I go to access policies. And I want to add an access policy. I don't need any key permissions. And permissions to secret is get and list. Get only, and then here is get, create, and list. I don't even think you need to create, but what the hell? It was in one of the official documentation at one point in time, but okay. Now I select the principal, which is like, who am I giving access to? Well, we know who. It's the identity that we just created. So that's gateway ILB ASE demo KV identity. That's the one. And I add. Now the identity I created, which is like a service account, has access to the KeyVault. It also says that my KeyVault must have soft delete enabled. So I want to enable this and save. So by enabling this, it's required for application gateway to have this functionality. So now my KeyVault is ready, my account is ready. Now I should tie everything together in the gateway. I go back to listeners and I want to create a new listener. ILB ASE demo, HTTPS or secure or whatever. And I choose here. Now this is the managed identity I want to use. This is the KeyVault I want to access. And I know my KeyVault does allow access to the managed identity, so I don't know what this error is. Okay, so I found out what was wrong. I did not click save after I'm done, and that's, I mean, it's stupid, but that's okay. So here, get create list. And the principal is gateway ILB ASE demo, okay, the identity. Add, and then I have to click save. That's what I forgot to do last time. So coming here, back to the gateway. Back to the listener. Adding a listener. And then ILB ASE demo HTTPS the public IP as normal, and I choose my certificate. First, I choose what identity I want to assign to my gateway, then the KeyVault, and then which certificate. So I have a certificate right here, and for this, I'm gonna choose the different type of listener, which is a multi-site listener, which means listen only for the request if it has api.thousandtech.com. This is just a domain I have handy for projects like these, like this one. So I'll just use this certificate I have on hand right now. And I'm gonna call this website this. And now I click add. And now that this is done, I need to go to my resource group again. I need to go to my public DNS and make sure that this actually resolves to the proper IP address. So if you check, I created a PIP, a public IP address here. That's the public IP address we're listening on, and it has a DNS name. So I'm gonna copy this DNS name. Then I'm gonna go to my my public DNS provider. That could be something like GoDaddy or Namecheap or any control panel you have, what you might have, and change it. For me, I'm using Azure Public DNS, so this is the domain, and I want to create a record set for API. So I create a record set for API, and it's not a type, it's a CNAME, and I want the CNAME to resolve to this name, right? And then I click OK. So it's creating the record set. It takes, I think, some time to reflect, but since it's new, I doubt that it'll take more than a minute. So I think we can try that right now. So now let's, as you see, now it's not secure. Now let's do this. And of course it's HTTPS. Let's see if it resolves. I don't know if it will that quickly. I'm sorry, it's not resolving. So I forgot something. We created a listener, but we didn't assign any rules to it. And I'm sorry if that confused you. So where is my listener? This is the rule that I already had in handy. I'm just gonna change the rule from the old listener to the new one. So instead of this listener, I'm gonna choose this listener, and now I'm gonna save. Everything else stays the same. And now it should be working. Just takes some time to update, but it will. I think it takes like 30 seconds to do that. So now that it's saved, the rule is saved, and now I hope this will work. Now I still don't know whether this resolved or not. Yeah, it did. All right. So now you can see the proper certificate, everything's working fine. Now, it's worth mentioning that that's only the case if I do HTTPS, but if I do HTTP, I'm not going to go anywhere. And that's because I don't have a redirect rule. So I'll come here back to the listeners, and I want to delete my old basic listener because I honestly don't need it. So I'm deleting this listener right now, and then I'm creating another listener. And the new listener, I'm gonna call it ILB ASE demo HTTP only, on the same public IP, on the same port. It could be multi-site, it could not, doesn't matter. I'm gonna do multi-site. Maybe I wanna host something else later on this. And now I created another listener. And now I'm gonna go to rules, and I wanna create another rule that is a redirect rule. So I add another rule, and the whole purpose of this rule is to redirect from HTTP to HTTPS. So it listens on this, and it shows it automatically because that's the only listener I have empty. All the other listeners are taken by other rules. So that's the only one I have right now. And the backend target is a redirection, and it's a permanent redirection to the other listener. You can exclude the query strings, but I don't want to. I want everything to stay the same. You can also do some pathing here if you wanted to do, and that's enough. And once I do that, I'll give it 30 seconds more, and then the HTTP to HTTPS redirection will also work. So now it's successfully saved the configuration. Now I can come here and do HTTP to my URL, and it would automatically redirect me to HTTPS and serve the proper page. So now everything is working as expected. So the only thing left here, well, let's say I have an application, and that application, now, as you know, right now I'm deploying to a web app. It's just a container running Nginx. But what if I want to actually deploy something that comes from a private repository? Or even a private CI/CD pipeline, that would be easy, but what if it's a public one? So an explanation to that is, if I have a CI/CD pipeline that lives on a private VNet, so I can easily peer this VNet with the existing VNet that we have here, and it would have access to the app service environment source control, and it would be able to deploy whatever code base I want or whatever container I want onto this website. The problem happens if I don't have a private CI/CD pipeline. So for that, I'm gonna show you a little bit about Azure DevOps, what we can do with it in such case. So I'm gonna go dev.azure.com. So first thing I'm gonna do is just log in to Azure DevOps. So here I have my DevOps organization. It's just maybe you have an organization that has a new projects in it. I'm just gonna create a new project, and let's just call it something like, I don't know. Let's just call it, ILB demo, ASE demo. Just sample project I want to create. And this isn't gonna live long enough to do anything. Creating a project, and I want to go into pipelines to do my CI/CD pipeline. I want to do releases, so I'm going to release a software onto a server. Let's assume my release is, so this is Azure App Service Deployment. I think this is what I want to do, so I'll add. Let's see. I don't think this is the one. I'm just deploying. let's assume I have an app service I want to deploy, like a container. I want a new version of the container I want to deploy. Is it this one? Yeah. So I gotta create a service connection. So I choose my subscription, and I create a service connection. The service connection is kind of like a service principal. I need to have access to my Azure Active Directory to do this. And this is basically creating a service account for Azure DevOps to be able to access the web app that I'm going to deploy on. And it's a web app for Linux, web app for containers on Linux. And I want to check the app service name. That's the app service name I have. If I'm deploying to an app service environment, I also want to check what is the name of the resource group and which slot am I deploying to. It's the production slot. That's self-evident. Now, okay, docker.io is the source of the image. It's Nginx latest. That's all. So I'm just deploying the same image on it, but I just want to see whether this will be accessible or not. So now I click save, okay. And now I create a release. And creating a release will basically just deploy or run this task that I have. I don't want all that. And I want to see the logs. I want to see it doing whatever it's doing as it's happening. So now it's getting me an agent from the cloud just out in the ether. It's going out there and getting me a VM that I can run this task on. Now, this VM, of course, is not on our VNet. It's on the public internet. It's on the cloud, somewhere in a Microsoft data center. I suspect, of course, it can get the image because the image is public, but it cannot get the destination, I reckon. And there you go. And if you check here, you will see the error of get address info. I couldn't find this address. I don't know what that is. And of course it couldn't because this doesn't exist as far as the agent is concerned. So what we need to do is create an agent that exists on our VNet. So I'm gonna go out here to this help article. It's called Self-hosted Linux Agents. And that just basically allows you to create a self-hosted agent somewhere. It could be anywhere you want. The easiest way to do it is if you want it to be on the same VNet is just to go to the project settings and you will find here something called agent pools. And I want to add a pool and it's a new pool. The pool type is an Azure Virtual Machine scale set. The self-hosted agent is if you want to install this on a VM yourself. It could be anywhere. It doesn't need to be on Azure at all. It could be in your own data center or your own home. It doesn't really matter. But this one is the agent lives on an Azure machine, a virtual machine scale set. And again, I choose the subscription. This is the same service connection. There is no scale set that I have. So I'm just going to create a new pool name right here. And I'm going to call it ILB ASE demo. And we'll call this agents. And the minimum number is 1. Sorry, the maximum number of virtual machines in the scale set is 1. I don't have the virtual machine scale set name yet, so I must go ahead first and create the virtual machine scale sets. So we'll do that and then we'll come and refresh this button and see if it shows up. So I'll come here to the same resource group and I will do a scale set. I want to create a virtual machine scale set. It's just like creating a virtual machine, but instead of one machine, it's just a bunch of machines on the load balancer. And the scale set name, again, I'll call it agent-ILBAC demo. And the location, I'll choose the same closest location to me. There are a lot of fancy configuration you could do. I don't really care about any of that. I'll just do this. The only thing I care about is the virtual network. And I want it to be on the same network. And it's on the management subnet. That's what I want. Use a load balancer. So do you want to load balance this virtual machine or not? Well, it doesn't really matter in our case because the agents are mostly going to be doing outside, like outbound connections, not inbound connections. The instance count is 2, is fine. I'm fine with that. And I'll just create. I just want to make sure I choose Ubuntu here or like a valid version of Ubuntu. There are a few versions that don't work with this configuration, but for this purpose, I think it's going to be fine. I'm going to download the private key. There's no harm in that. Although I might never need it. So it's creating the virtual machine scale set. I'll pause the recording until this is done. So the deployment is done. It took about 3 minutes. And now in theory, I should come here. And if I refresh this, I should be able to find my virtual machine scale set right here. And number of agents to keep in standby. 1 is the good number as well. So I only want 1 agent to be on standby waiting for any task to happen. And now I create. So now this is my pool. Now I can go back to my project, go back to the pipeline, release pipelines, and I want to edit the pipeline. And the only difference is I want to click on this job and in the run on agent, instead of the Azure Pipelines agent, which is the default agent, I actually want to use mine. which is my own specific agent pool that I created. And then I save this. And now let's create a new release. So this release is going to be running on the same VNet. And the only reason is that I'm using my own agent. I'm not using an agent out there on the internet. I'm using an agent out of a pool that I've deliberately put on the same VNet. So again, we have to wait until one of the agents is available. It sometimes takes a while. It has to be sure that the machines are not doing anything. So we'll give it a while, and I'll pause the recording and come back again. And now we're back. Here you go. You can see successfully updated deployment history and the service application URL. And that succeeded because, well, now it could reach, because on this VNet, this is a valid URL that actually resolves to something that is reachable. This is basically how you privately and securely deploy your code onto an Azure App Service environment that is internal, that's not connected to the internet in any way, shape, or form. And that's it. I think that concludes our demonstration. Just to get back to, this is basically the setup we did. We have a customer using a browser to talk to an application gateway that presents an application hosted inside an app service environment. Now, the rest of the details, I'm sure you can manage by yourself. Like if this application would have had to talk to a database, then that database as well. You can use something like on Azure, you could use something like a managed instance that would exist on the VNet only and is only reachable within the VNet. There is also some fancy stuff you can do with private links and that sort of stuff. And we've published this application onto the gateway securely. So what I want to show you just quickly before we end this video is this is not related only to app service environment. Like app service environment is all fine, but you can have anything here inside an app service instead of an app service environment. And this is basically one of the architectures also that I create a script to deploy for you. Let's say you have an application gateway here and you have an API management that is internal. So this API management gateway is also on an internal load balancer, is not connected to anything else externally. And you can have a backend subnet here. In some customers, this is either it's either an app service environment that contains backend services that they use and that they expose using API management or application gateway or both. And or it might contain a Kubernetes cluster that you create also. It lives completely private and so on. And it's all the same thing. You go through the same process when you're doing that kind of secure infrastructure where you have everything created privately inside the VNet, and then you expose only what you want using an application gateway or a web application firewall and so on. I think that concludes the video. Please feel free to leave me any comment or ask me any question. I hope to be very active in the comment section. Also, be sure to check my website. It's zoomspeaks.tech. And feel free to read any of the articles I have in there. I'll be also posting the videos here, and any updates you can you can subscribe to the newsletter to get any new content.